Yes, hello students, welcome back to our channel. So in this video we are going to talk about two new concepts called precision and accuracy. Let me directly go for the definition of these two. Precision refers for the closeness of various measurements for the same quantity, whereas accuracy refers to the closeness of a single measurement to its true value. Okay, so generally you have heard these two terms, precision and accuracy. If not precision also, you have heard this term accuracy. The value is accurate. Clear? You have heard about this term accurate. So generally, why do we use these two terms? When we are doing any chemical experiment, generally we will not satisfy for a single value. We will take multiple values. Example, when we are doing titrations. Titration, this is just an example. Or when we are doing any chemical experiment, we will generally take 2 to 3 values. Okay? We will do 2 to 3 tests and we will take the 2 to 3 values. Okay? So based on the difference of these 2 to 3 values, we will say whether the particular experiment, particular values that we have got in the experiment is accurate or precise. Okay? So now let us explain with an example. So a man has done an experiment and it is proved that the true value is 2.00 gram. Okay, so any experiment, a scientist or a chemist have done some experiment and he discovered that the true value or the correct value is 2 gram. Okay, any experiment. So we have two students, student A, student B and student C. Okay, these three are doing the same experiment, and student A gets 2 values in the first trial and in the second trial. Clear? We are doing 2 trials for this an unknown experiment. Just say unknown experiment. Okay, this is the exact value, true value, this is the correct value. Okay, so if student A performs the same experiment, he will get the values of 1.93 grams on the first trial and 1.95 grams on the second trial. Just observe the values. Okay, and the next man, student B, he will get the value of 1.94 or 1.95 grams and 2.05 grams. Okay, this is the case of student B. Okay, so what is the value of student C? He will get 1.99 grams and 2.01 grams. Don't get confused, it's not 9, it is grams. Okay, so these are the values, experimental values which is given by student A, student B and student C. We know that the correct value of the experiment is 2 grams. That is the correct perfect value. Student A performed the same experiment. He got the value of 1.93 and 1.95. If we observe this, if we just analyze the values, the experimental results that is given by student A is 1.93 and 1.95. You feel that these two are almost similar and these two are very close. 1.93 and 1.95 are very close, but it is not the correct value, or it is not even near to the correct value or the true value. True value is 2.00 grams. But the values which is obtained for student A is 1.93 and 1.95. Clear? So they are not accurate. That means they are not near to the true value, but they are close. close. 1.93 and 1.95, they are closeness in their measurement. So you can easily, now let's go back to the definition of precision and accuracy. Precision means it refers to the closeness of the various measurements for the same quantity. In first trial also, in second trial also, student A have did the same experiment and have got different values, and no problem, these two different values are close enough, 1.93 and 1.95, but they are not accurate. That means they are not equal to the true value of the correct value. So now you can easily say that the values which is obtained by student A is precise, but not accurate. But not accurate. Clear? This is not accurate. This is only precise. So now let's go for the second one of student B. He have got the values of 1.95 and 2.05. Okay, he made the same experiment. He made the same two trials. In one trial he got 1.95 as the answer, and in one more trial he got 2.05 as the answer. We know that the true value for that particular experiment is 2.00 grams. Now if you just observe this value, these two values are not even closer, 1.95 and 2.05. It is a huge gap is there between these two. These are not even closer. So okay, so is this true for the accurate true value? No, this is not even close to the true value also. So you can easily say that this is not precise. This is not precise. Yeah, why? Because there is no closeness in this value, so it is not precise. So is this accurate? What is the meaning of accuracy? Accuracy refers to the closeness of a single measurement to the true value. Is this accurate? If you want to tell accurate means this value should be closer to the true value. So is this closer? No, it is not, because 1.95, 2.05, there is a huge gap. It's not even precise, and 1.95 and 2 true value. So this is not close for the true value also. So this is not even accurate, and 2.05 also, this is different. There is huge difference between 2.00 and 2.05. This is not even accurate. So this value, student B's value, is not even precise and it is not even accurate. Clear? So now let's go for the third one, student C. We have got the values of 1.99 grams and 2.01 grams. If you just observe carefully these two, let's talk about precision first. Okay, is this precise? Yes, it is precise. How? Because 1.99 and 2.01 almost they are closer measurements. 1.99 and 2.01. There is no such much of huge gap between these two values. So these are precise. We are not talking about the accuracy. We are not comparing it with the true value now. Okay, so these two values are precise. How? Because there is some closeness in measurement of these two values. Let's check that. Precise, yes it is. These two values are precise. Whereas if you check for the accuracy 1.99 grams, 2.00 grams. Yes, this is almost accurate. Okay, it is because it is having closeness to that of the true value. So the first trial results of student C is accurate. And in case of second trial also 2.01 grams, and it is almost equal or almost it is very closer to the true value, that is 2.00 grams. So the second trial value is also accurate. So we can tell that the values, the experimental results of student C's first trial and second trial is both precise and accurate. Clear? So with this example, I think you have got clear information regarding the precision and accuracy. Precision stands for the closeness of various measurements for the same quantity. It may be accurate or it may not be accurate. We do not worry about the true value here while we are looking for precision. only the obtained value should be closer. That's it. And whereas accuracy, it refers to the closeness of a single measurement to the true value. In this case, the values which is obtained should be closer to the true value or the confirmed value or the confirmed or perfect results. Clear? So then we can call it as accurate. This is regarding precision and accuracy. Okay, next thing is we are talking about a dimensional analysis. We call it as interconversion methods. So, in this, you have seen the 7 SI units for 7 physical interconversion of units. Actually, it is interconversion of units. You have seen the 7 SI units for 7 standard physical quantities. So it is known that length can be measured even in centimeters also, and also in inches also, and even in feet also. So for the same physical quantity of length, we can measure in centimeters and also even in inches also. Okay, both are same, but the units are different. Okay, physical quantity is same, whereas the unit is different. One is centimeters and one is inches. Clear? So in dimensional analysis, we will dealing with the interconversion of units. Clear? So converting length in centimeters to inches, converting from metric units to non-metric units. Clear? So conversion from metric units to non-metric units. Metric units, as you know, the SI units we have studied in that table, and converting from them to non-metric units, the normal units that we are talking about. Clear? So length, and for example, even if you take time, you can tell even in seconds, okay, minutes, hours, and even in day, week, month, year. You are talking about the same time itself. 60 seconds is equal to 1 minute. Okay, if you tell 60 seconds, it is the same meaning. If you tell even 1 minute, it is the same meaning. Okay, so in dimensional analysis, we are converting the same physical quantity from one unit to another unit by a method called conversion factor method. By a method of conversion factor method. Clear? So what do you mean? This is also known as factor label method. So in this conversion factor method, we'll get the ratio of the units of the same physical quantity. Clear? So it is the ratio of conversion method. It is the ratio of magnitude of the same physical quantity in two different units. Okay, so we will be dealing with the same physical quantity, but we will be getting the ratio of two different units. For example, you have length. I have said that length can be measured in centimeters also and inches also. So writing the conversion factor for this same physical quantity, that is length, in two different units, that is centimeter and inches, is you know that 1 inch equals 2.54 centimeters. Okay, 1 inch is 2.54 centimeters. So what is conversion factor? It is the ratio of magnitude of the same physical quantity in two different units. Two different units is one is centimeters and one is inches. So we need to take the ratio of this. So it is 2.54 centimeter by 1 inch. Okay, this type of representing the same physical quantity, magnitude of the same physical quantity in two different units in the form of a ratio, we will call it as conversion factor. Okay, so this is the way of representing a conversion factor. Getting the same physical quantity, 2.54 centimeters, we are talking about the same physical quantity, that is length. 1 inches, we are talking about the same physical quantity, that is length itself. But the units are different, centimeters is different, inches is different. Clear? So why we are equating this to one unit? It means that 2.54 centimeter is, when you convert it to inches, it is 1 inch itself. If you convert 1 inch to centimeters, it is 2.54 centimeter itself. So we are equating this to unit. Clear? So let us take an example for, let us solve a problem regarding this dimensional analysis. It is a piece of metal is 3 inches long. 3 inches long. So what is its length in centimeters? Clear? So we are talking about the physical. What is the physical quantity we are talking about? We are talking about the length. What are the two different units they have given? One is in inches and one more is in centimeters. First, how can we convert from one unit to another unit? By using a method of conversion factor method. Conversion factor method, it is the ratio of magnitude of the same physical quantity in two different units. Now let us write the conversion factor for this. Conversion factor is unit equals, we have inches, we know that 1 inch equals 2.54 centimeters. Clear? So now let us write the conversion factor. Conversion factor unity, it is 2 per ratio of same physical quantity in two different units. One is in centimeters and one more is in inches. Clear? So this is the conversion factor. We are talking about length itself in two different units, one is centimeters and one more is inches. So we have got the conversion factor. So what is the question now? A piece of metal is 3 inches long. What is its length in centimeters? Okay, they have given in inches, we have to convert it into centimeters, and we have got the conversion factor also. So now let us try that. 1 inches equals 2.54 centimeters. So 3 inches equals 3 into conversion factor, that is 1 inch. So if you just multiply this 3 into 2.54, you get the value of 7.62 centimeters. Yeah. So this is how you convert the unit of one physical quantity to another of the same physical quantity. It means that a piece of metal is, if the piece of metal is 3 inches long, then in centimeters it will be 7.62 centimeters. So now let us take one more example. How many seconds are how many seconds are there in 2 days? How many seconds are there in 2 days? Now, the physical quantity that we are talking about is time. Time is the physical quantity. So we have 2 units. One is in seconds and one more is in days. These are the 2 units. So they have given in days, we have to convert it back to seconds. Can be converted directly, but in case of last problem, inches to centimeters, we had direct relationship. That means 1 inch equals 2.54 centimeters. So we have written the conversion factor and we have directly got the answer. But in this case, there is no direct relationship between days and seconds. Seconds, we have to go for minutes. Minutes, we have to go for hours, and hours, we have to go for days. Okay, so we have to convert, but the units are different, but the physical quantity is same, that is time itself. So first, let's go for days to hours, hours to minutes, minutes to seconds. Clear? So now 24 hours makes 1 day. Clear? 24 hours makes 1 day. This should be equal to unit. Clear? 24 hours is also same and 1 day is also same. So now we need to go back to hours to minutes. So 60 minutes is equal to 1 hour. 1 hour. This should be equal to unit. Because this is the conversion factor. This is the conversion factor for the above problem. Clear? So we have got for minutes. Now we have to convert it to seconds. So 60 seconds equals 1 minute. Clear? So now we have got the conversion factor. Okay? From days to hours, hours to minutes, and minutes to seconds. So now directly we can convert from day to seconds. How? Just we have to use this conversion factor. So now let's go back to the question. How many seconds are there in 2 days? This is for one day. Clear? So we need for 2 days. So 2 into 24 hours by 1 day. 1 day into 60 minutes by 1 hour. 1 hour into 60 seconds by 1 minute. So after doing all the calculations, what you get is 1,72,800 seconds. Yeah. Do the calculations when you are free at your homes. Yeah. So how you got the units? Units how you got is it is 2 day. Okay. Day and day gets cancelled, and hours get cancelled. Minutes and minutes get cancelled. Okay. After you multiplying all these things, 2 into 24 into 60 and 60, you get 1,72,800 seconds. Clear? So this is how you convert from 1 minute to another. This concept we call it as dimensional analysis. Okay, students, we are ending up here. Thank you.